Welcome to the Planet of Maths channel. In this episode, we'll talk about the properties of functions. But before we move on to the functions themselves, here I think it's worthwhile to look for an analogy with the temperature chart. Just like here, we have the temperature chart in a certain location. Temperature was measured between midnight and midnight. That's the domain of this function, from midnight to midnight. The range of this function is the range of temperatures that appeared here, with the lowest being -3 and the highest being 4. So the range is from -3 to 4. Zeros are when the temperature was 0, so zeros are here and here. In functions, there's also the question of when a function is increasing and when it is decreasing, and it's exactly like with temperature. The temperature was dropping here from midnight to 2 a.m. During those hours, the temperature is decreasing, so the function decreases. Then the function is constant between 2 o'clock and 5 o'clock. Then the function starts to increase from 5 o'clock. Up to 1 p.m., the temperature is rising here. So for x's from 5 to 13, the function is increasing, and the temperature rises. Then from 1 p.m. to midnight, the function decreases. That means for x's from 13 to 24, the function decreases. And one more thing, when the function is positive and when it is negative. Function is positive when the temperature is positive. Positive temperature is in this segment. Here are the temperatures and function positive, and this happens between 8 a.m. and 9 p.m. So, for x's from 8 to 21, the function is positive, and the function is negative in 2 intervals. From 0 o'clock, here we have negative temperatures until 8 o'clock. So, between 0 and 8, the function is negative. And the function is negative from 9 p.m. to midnight. Here too, the temperatures are negative, meaning the function is negative. Now we move to a specific example, not talking about temperatures, mainly about functions. We have a function graph, and first off, we need to state the function's domain. The domain of the function are the hours when the temperature was measured, means starting from -6 o'clock up to this hour, meaning till 9 o'clock. The domain written in an interval notation is, from this side we put the bracket, because here we have a closed circle. From -6 to 9, including 9, so we also put the bracket, because the circle here is closed. The function's range are the temperatures that appeared here, the full temperature range. We start from the bottom. The lowest temperature was here. This is the lowest value. The range starts from -3. They go up to a point, not this one, because we have an even higher point. And that's the highest temperature, which is 5, and that's the function's maximum, which is 5. The range written in an interval notation, we put a bracket again because the temperature of -3, meaning the value of -3, is reached. There is a closed circle there. If there were an open circle, we would need to use a parentheses, but we have a bracket. And so it is up to 5. At 5, we also put a bracket, because there is also a closed circle here. What is the function value when x equals -2? So they ask us what the temperature was at -2 o'clock, when x equals -2. So we are at this point. What is the function value? The function value is here. We read it from the y-axis, and the function's value is 4. We can write down that f of -2 equals 4. What is the function value when x equals 4? So we're looking for x equals 4 this time. Means 4 on the x-axis. So at 4 o'clock. The temperature was then equal to 1. When x equals 4, the function takes the value of 1. We note f of 4 equals 1. And what is the function value for x equals 6? X is equal to 6 in this place. The function's value then goes up here. This is the maximum value of the function, which is 5. At 6 o'clock, the temperature was 5 degrees. For the x of 6, the function takes the value of 5. That is, f of 6 is equal to 5. Now we have to find out when the function value equals 5. Since we are asked about the x's, and we know the function's value, we are looking for values on the y-axis. The value should be 5. It's as if it's the value of temperature. At what time was the temperature equal to 5 degrees? It was in that place, meaning the function takes the value of 5 when x is equal to 6. The function value equals 5 for the x equals 6. and only for this one x is it so. When does the function value equal 3? The function value equals 3, meaning 3 on the y-axis. Values are on the y-axis. Here is the value 3. This occurs when x is equal to 0 at 0 o'clock. But also here to the left, we have a point where the function's value is 3, and it's right here. At negative 4 o'clock, for x of negative 4, the value of the function is then 3. And we also have points in this spot. If we were to draw a horizontal line here, in total, we have 4 situations where the function's value is equal to 3. Here we have the function value is 3. And this happens for x of 5. And the last point, when the value is 3, is right here at this spot. It is about 6.5. For the x 6.5, the value is also 3. For each of these 4 x's, the function's value is equal to 3. Now we'll look at when the function is increasing and when it is decreasing. First, when the function is increasing, meaning when the temperature here was rising. The first situation where our temperature is rising is here. It happened between negative 6 o'clock and negative 2 o'clock. That is, from -6 to -2. The function is also increasing in the second interval. Here, the graph is going up too. So here it's also an increasing function. And this happens for x's from 4 to 6. We can note that the function is increasing. Sometimes you can write it down this way. This happens only when x belongs to the first interval, which is from -6 to -2, and here we have open intervals. We always have an open interval when we talk about increasing or decreasing function, so we need to put parentheses on both sides. Or also in the second interval from 4 to 6, also an open interval. In these intervals, the function is increasing. When is the function decreasing? A function decreases when it goes down. Here, the function is going down. This happens for x's from -2 to 4. Here, the function decreases, but it also falls, meaning it goes down. From this point to that point, the function falls. And this occurs during the hours, that is for x's from 6 to 9. We write this down in a more mathematical way. The function is decreasing, meaning it goes down, when x belongs to the interval. The first interval when the function is decreasing, that was the first thing here. The interval is again open from -2 to 4. Union another interval from 6 to 9. In these two intervals, the function is decreasing. And here we also have when the function is constant, which is when the graph is horizontal, meaning the temperature doesn't change. In this graph, we don't have such a section, so the function won't be constant anywhere. We don't have such a section. The function's zeros are when the temperature was equal to 0. There are 2 zeros of the function. Here is a 0, and it is the x, which means we read it from the x-axis. -5 is the first 0, and 8 is the second 0, because here too, the value is 0, meaning temperature is 0. When does the function take positive values? For which x's? This function is positive in this segment here. These are all positive values, meaning positive temperatures. It happens between -5 and 8 o'clock, meaning from -5 to 8. Then the function is positive, and we write it like this. F of x is greater than 0, meaning positive, when x belongs to the interval from -5 to 8. But now, should this interval be open or closed? Function values should be positive. What's the value for x minus 5? For the x minus 5, we're exactly on the y-axis. And here the temperature is 0, looking for this analogy to temperature. We are asked when values are positive, meaning not 0, but they should be greater than 0. If we're at 0 here, then this number doesn't interest us. If we go slightly beyond -5, the temperature becomes positive. But at -5 itself, the temperature is not positive. It is 0. This isn't a positive value, and we have to put parentheses here, meaning it is everything above -5. On the other side, similarly, at the 8 itself, the function's value is 0, and we want it to be more than 0, which means positive. So the number 8 itself doesn't concern us. The function values are positive between the numbers -5 and 8, but excluding these two boundary numbers. When does this function take negative values? Negative values are below the x-axis, so here we have negative values. This is for x's from -6 to -5. Negative values are also between the x's here. In this place, we have a piece of negative values, which is between 8 and 9. And the mathematical notation, f of x is less than 0, meaning the values of the function are negative when x is in the interval from -6 to -5. That is the interval. Just pay attention now. What is the value of the function for x -6? -6 is on the edge of the interval, but that -6 is slightly different when on this edge of the interval. For -6, the value of the function is -3, which means for -6, the function value is negative. So we need to include this -6 in the interval. In this number, -6, there is a negative value, and at the number -5, the function's value is no longer negative because here it is 0. So at this point, we're using an open interval. And we have another interval there. It is from 8 to 9, meaning this part. At 8, the temperature is 0, which means it's not negative. The 8 here doesn't concern us because it's not relevant to us. I'm interested in negative values. That means at 8, I put parentheses. And at 9, this temperature, or rather the function's value, is -1. So this is a negative value of the function. Here we close the interval. Open at 8, closed at 9. If the dot here were open instead of filled in, then we would have to make this interval open as well. But in this case, it has to be closed. The maximum value of this function is, now we're looking for the highest value. The highest value is the highest temperature, which is right here. Here we have the highest temperature. The highest value is 5. The maximum value of this function is 5. And this value 5 is taken for x. We read x from here. For the x equals 6. We can write that f of 6 equals 5. So for x equal to 6, the function takes the maximum value, that is y equals 5. What is the minimum value of this function? The minimum value meaning the lowest point. The lowest point of the graph is here, and this lowest point is at the level of -3. The minimum value of the function is -3. And that -3, the minimum, is taken for x -6, as if it were at -6 o'clock. For x -6, which is here, the function's value is the smallest, the minimum, and it is -3. f of -6 equals -3. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.